Class?
Yes.
Okay, we have a lot of missing people here, so I'm hoping these missing people are going to go and actually do, go and watch the videos. So, I did this on the board the other day because someone asked it, but I want to actually add it to my video because a lot of people weren't here that day. So, now, tangent. We know tangent is, very good, sine of a cosine. So, I could say that y is sine of x over cosine of x. And now I'm going to look at it as this is going to be a quotient rule, and I can actually do this. So f and g, f prime. So what is the sine of x? What is the derivative of sine? Sorry. Negative cosine. And what is the g prime? What is the derivative of cosine? And just so you know, this negative cosine is incorrect. It's just normal cosine. Okay, remember the circle?
Yeah.
So we start at the top and it goes to a positive cosine first. Okay, so, and then cosine derivative cosine is negative sine. There we go. Alright, so my formula, f prime g minus g prime f over g squared. So f prime is going to be cosine times g, which is cosine, minus g prime, negative sine, times f, which is sine, and all this is going to be over g squared, which is cosine. Here, just for the sake of argument, I'm going to do it like this. So normally that's not how you see it. You see with the cosine with the 2 right there, but for that discussion that we had yesterday, it means the same thing. So I just want to show you that it is cosine squared there. All right, negative negative on top gives me a plus, so that's cosine squared x plus sine squared x over cosine squared x, like that. And what is the one thing that we always forget about that trig identity? Yep, cosine squared plus sine squared equals 1. So this is going to give me 1 over cosine squared x. Okay, so cosine squared. But now 1 over cosine is a reciprocal identity. That is a reciprocal identity. So that is secant. Because 1 over cosine, or 1 over x, is secant. So this is also going to be equal to secant squared x. So both answers are correct. But we normally just go secant squared for the answer. Yeah.
So it's already given to you, you just prove it?
I proved it for you. So let's say, for instance, you forgot. If I say, hey, what's the derivative of tangent? And you can't remember off the top of your head. Can you do the math? Yes. Because with trig, you have the quotient rule or the product rule, and we could rewrite every single one of these using quotient rule to find the derivatives. So I could do the same thing and say, hey, what's the derivative of secant? What do we know? What do we say secant is? 1 over cosine. So if I say y is equal to 1 over cosine x, which is the same as secant, right? I could say, hey, this is going to be my quotient rule. Okay, so that would be f, and that would be g. F prime is 0. G prime is negative sine f prime, so it's 0 times g cosine minus g prime, which is negative sine, times f, which is 1 over cosine squared x. And this is 0 times cosine is 0. Negative negative makes that a. So you get a positive sine x over cosine squared x. So technically that thing is correct, right there. But that's not normally how you see the answer written. Because if you look it up, I have it on another page of the tables. It's going to show you, it's going to tell you what it is. But right now I'm showing you how to do every single one of these. All the reciprocal identities you do like this. So I'm going to rewrite this. So I'm going to separate that square. So I'm going to say sine x over cosine x times 1 over cosine x. That's still my cosine squared, isn't it? Yeah? Isn't it? Yeah? Yeah, you zoned out on me. I saw it all glossy. So, is that still cosine times cosine, cosine squared? Okay, so the way that we normally read this is, what is sine over cosine? So this is tangent times, what is 1 over cosine? Secant. So, normally they put it the secant first, so I'll put it here because that's normally how you see it. Secant tangent. So the derivative of secant is secant tangent. Or tangent secant, but like I said, normally when you see this written out, it's written as secant tangent. Or you could just go, hey, I did the math. This is correct. Does that make sense? So that right there is going to help you with every single one of those trig identities or the trig problems. So you could do the work yourself. You don't have to memorize what everything is. Does that make sense? Yeah? Okay. All right. So here's the list. Like I said, you don't have to memorize it. Huh? You have the link? Yes, there is a domain. Because sine and cosine are waves, right? Okay, so the domain, it's always going to go from infinity to negative infinity and infinity, right? Okay, but tangent is sine over cosine. So tangent would be undefined everywhere that cosine is equal to 0, right? Yeah. So because sine over cosine, whenever you have a fraction, you're going to have domain restrictions or undefined at location which at the bottom is equal to 0. So that's why I get for the tangent, I'm going to have restrictions there where my derivative or where my denominator is equal to 0. Okay, so cotangent is cosine over sine. So that means that it's going to be undefined everywhere that your sine is going to be equal to 0. Does that make sense now? Okay. All right, evaluating second derivative of a trig function. Find f double prime pi over 4 if f of x equals secant x. Oh, hey, did we already do this? So the first derivative is, so f prime of x is, what do we say the derivative of secant is? Secant tangent. Now we got to get to the second derivative here. So if I have to get to the second derivative, what rule do I have to use now? Not power. What's happening right about her? Product rule. There we go. So product rule. So product rule. So I'm going to label everything as I go. Change colors because why not? So f prime, what's the derivative of secant? Okay, so no. So that goes with this one right here. Yeah, our formula have f and g's, but it's not the same as this. That's only going for this. That's kind of why I changed colors here.
Like for like that whole part.
The derivative of this is secant tangent.
No, not that. The you know how you're writing f prime 1 equals secant tangent.
No, f prime of x.
F prime of x. Oh.
Equals secant times tangent, right? Because this is my original function here. And we know, because we just did it, what was the derivative of secant? Secant tangent. Okay? And so, look, I have another secant here. So the derivative of this is secant tangent. Now, g prime, the derivative of tangent, didn't we already figure out what derivative tangent is? Secant squared. Now we plug it into the product rule. I'm plugging in the product rule, so it's f prime g plus g prime f. Huh? So f prime is going to be secant tangent times g, which is tangent, plus, it's a tangent x, secant squared, times f, which is secant. Oh, it's not y, it is f. Sorry. F double prime of x. Now, do I need to go arrange and coordinate and do all that other stuff? I really don't. Because in this case right here, I'm plugging in. Okay, so pi over 4 my unit circle. What quadrant is pi over 4 in? First quadrant, right? Now, and it's right there. And if I'm thinking about doing a little bit of mental math here, if I'm thinking about it, the x value is rad 2 over 2, okay? The y value is rad 2 over 2. So they're both. So we know tangent is sine over cosine, right? So it's the y over x. It's going to be 1 because I have both the y value and the x value being the same. So there we go. So that's going to give me, right here, it's going to give me 1. So 1 times 1 is 1. So I'm going to do f double prime of pi over 4 is going to give me, those two are going to give me 1. Secant is the x value, 1 over x, right? There's a reason why these are called reciprocal identities. Okay, would just be the reciprocal, right? So it's going to be 2 over rad 2. So it's a reciprocal identity. I take my secant value, whatever the cosine is, whatever the value I have for cosine, and just flip it over. That's how I get those ones. Now, am I supposed to leave it like that? Say no. Because why? Very good. Rationalize. That's the word I was looking for. It's rationalizing. So 2 over rad 2 times 1 times 1 plus secant squared, which is 2 over rad 2 squared times 2 over rad 2.
How'd you get 2 over rad 2? I didn't understand that.
All right, before the fire alarm went off, Blade was asking, how did I get that value? So I'm going right here. You ready? Okay. So you were asking, how do I find the rad 2 over 2, right?
Yeah.
So in this quadrant 1, my x value is rad 2 over 2. My y value is rad 2 over 2. So in a trigonometric circle, it's always x comma y. And when I'm looking for the answers, the x values is the distance going from here like this. So in this value right here, let's say this is my angle theta here, and we need to go way old school, okay? Remember some old hippie caught another hippie tripping on acid? Sokotoa?
Oh, nobody said that.
I've never heard that in my entire life.
Some old hippie caught another hippie tripping on acid.
I can remember that.
I know, it's easy to remember, right?
Yeah.
Okay, so we want to know cosine, right? Cosine is adjacent and over hypotenuse. Adjacent would be this value. My hypotenuse is this value, which is, on my unit circle, it's always 1, isn't it?
Yeah.
So adjacent over hypotenuse is x divided by 1, which is just x. So my cosine is always this first value, and sine is this second value. So it's like saying x comma y, it's always cosine comma sine. So my value that I'm looking for was right here. So that's what I got that from my unit circle.
You said sec. No. That's for secant. How do you get?
Yeah,
that?
you're right, secant. Okay, so that's sine and cosine. But what is secant?
It's 1 over cosine.
Yeah, secant x is equal to 1 over cosine x, right? There's a reason why this is called the reciprocal identity. Okay, so I'm going to do the math on this one. So this is 1 divided by rad 2 over 2, right?
Yeah.
But we can't have a fraction over fraction. I have to multiply, right?
Yeah.
So I'm going to turn this into, so this is going to be 1 times the reciprocal of the bottom,
Yeah.
which is going to give me 2
Oh, okay.
over rad 2, where it's just 2 over rad 2. So knowing it's a reciprocal identity, I could take whatever my answer is and just flip it over.
Yeah, I get that.
Oh, is that better? Okay. All right, so there we go. So now we're finishing plugging it in here. So this first one right here is just going to give me 2 over rad 2 plus, isn't this going to be 4 over 2, isn't it? Yes? When I square 2 over rad 2, that's going to be 4 over 2, right?
Yeah.
Okay, so it's 4 over 2. Okay, so it's 4 over 2 times 2 over rad 2. Right?
Yeah.
So can I cancel those out? And so what am I left with right there? 4 over rad 2, right? and I left this like this without rationalizing the denominator for a reason, because I saw, hey, I might not need to, because if I rationalize that first one, I'll have to rationalize the second one before I can combine like terms. Now, can I combine like terms? Yes. So rationalize at the end when you have to. So common denominator is going to be rad 2, so that's going to be 2 plus 4 is 6 over rad 2. Now I'm going to rationalize. So multiply top and bottom by rad 2 over rad 2. And what's that going to give me? 6 over 2, which will reduce to 3. So my whole answer for this, so f double prime of pi over 4 is going to be 3 rad 2.
We have to, could we have ended it on 6 or rad 2?
You could have, but you got to simplify for these anyway. So yeah, you technically don't have to rationalize. But usually, if I have to use my answer in something else, or plug it in to try and see, because what is the second derivative? What did we say second derivative represents? Acceleration. Very good, acceleration. So would I say that my acceleration is 3 rad 2? I could, but that's normally not how you would normally like plug it into the calculator, see what you get, right? Because do you really know how fast you're going if I told you, hey, you're driving too fast, you were speeding, you were doing the square root of 73. And so you're like, yeah, what is square root of 73, right? School zone. So you're like, yeah, no one does that. So you approximate what it is, and so you would throw it in there if you have to use it for whatever.
Then there's not speed if it's in the school zone.
Okay, so now, what's the rule about speeding?
Maybe 25.
Okay, but if the speed limit is 15, you have to go 5 over or 500. So yeah, you could actually get a ticket for going too slow too. Yeah, especially on highway, whenever like safety's involved, especially like if you're on the highway and you're doing 45 at a 65, you're gonna get pulled over because you're impeding the flow of traffic. That's actually the speed limit is posting, and most people only worry about going too fast. They forgot that there is.
Yeah, I didn't know there was a minimum as well.
Yeah. Like, have you ever tried driving on the road and someone's going super slow and everyone's trying to go around them?
I mean, I've seen it.
Oh yeah. Okay. Huh? Yes, it is dangerous.
I'd be cutting up traffic though.
Uh-huh.
Like I'm swimming through there.
Oh man.
I'm so good at it. That's why I get to school so early.
Oh my goodness. Anyway, all right. So this one right here. So because of lack of time. Okay, I'm just going to point this out. Okay, velocity would be my first derivative. Acceleration is my second derivative. So that's why I want to bring that up. So make sure you guys like, share, and subscribe. The homework is due Tuesday, and next week, Tuesday should be the test. So AP Classroom has your review for all those people that haven't started it yet.